66.4 in from the left, so we need 66.4 in from the right.
Okay. So 293.6.
And so x equals 293.6. And so what you see there is cos x is equal to cos 360 minus x. And that's a way to get an additional solution within the range.
Okay.
Okay, how about this?
Okay, so inverse tan minus 2.
Yep.
Minus 63.4.
0.4 degrees. So that's this one here, it looks like.
Okay.
Minus 63.4 degrees. So yeah, minus 2. Okay, how can we get the other two solutions?
So the minus 2 goes across. Is that we're following that dotted line, right?
Yep.
So the second solution would be okay.
Just want to see something. This is 10.4 simple trig equations.
Is the second one 423.4 because it's minus twice?
Say it again, sorry.
423.4.
And how did you get that?
Because 360 minus 63.4.
That's for cos. This is tan graph. How often does tan repeat?
Every 90? Or every 180, sorry.
Every 180, yeah.
Okay.
So it follows different rules from cos. And so...
There's 180 minus 63.4.
yeah, it's like minus 63.4 plus 180. What is that?
$116.6.
116.6 degrees. And we have an additional solution between 0 and 360.
Yeah, I'm not sure.
Add 180 again. It's going to be 180 to the right of it. So
okay.
It's repeating every 180.
296.6.
296.6. Well done.
Just a question. Before, on the cos, you were doing 360 minus whatever you got, but you're adding 180 every time.
And so what this shows you is that tan x is equal to tan 180 minus x. Sorry, 180 plus x. Yeah.
Okay. So cos is equal to cos 360 minus x.
Yeah, cos is equal to cos 360 minus x. And sine, will we see sine? Sine x is equal to sine 180 minus x. Yeah, that was the first thing we saw.
Okay.
Yep. And here's how it works. So it's basically your first answer is always arc sine, arc cos, arc tan, you know, depending on what it is. The second answer for sine, 180 minus the first one. For cos is 360 minus theta. And for tan is 180 plus theta.
Okay.
That gives you two solutions. Any more solutions that you need, you either add 360 to your previous answers or you subtract 360 from your previous answers, depending on which way you want to go. And that's because if you have an angle and you spin a 360, it goes back to where it is. So the sine of 30, we could check. So sine 30 is a half. And we could do the sine of a 30 plus 360. And that's going to be a half. Or we could do, let's say, the sine of 30 minus 360 minus 360. And it's still a half. Because it just
All
goes...
I've got is a black screen, so I didn't see the calculator.
Sorry. All right. If I need it, it was just basically it gives you the same thing, like sine 30 plus 360. That's all. Okay. How about this?
So the first one is inverse sine minus 1.
Yeah.
Minus 90.
So that's minus 90. How can we get another solution for that?
Is it minus 180?
Yeah. Well, sorry, sine theta is equal to sine 180 minus theta.
Oh, okay. So it's 180 plus 90. 270?
Yeah. And that is, so theta equals 270 degrees. I think that's a very special one. There's only one solution for that. Yeah. Okay, let's try B.
Inverse tan of root 3, sorry.
Yep.
60.
Okay. And how do we get another one?
And then it would be, is it plus 180 plus 60? So 240.
Yeah. And how about...
Just a second.
Mm-hmm.
Sorry.
Alright.
So there's only one answer for B?
For B, no. We got two answers, 60 and 240. So maybe I'll just...
Okay, so
theta is equal to 60 and 240. I kind of skipped over. I'll go back to A at the end. I just want to do kind of normal stuff first. So how about C?
inverse cos is 0.5, 60.
Okay.
And then is it 360 minus 60?
Yeah.
300.
Yeah. And so those are our two solutions for that. These are our two solutions for tan. For sine, do you remember that the way you'd get a second answer? Well, sorry, a third answer, I suppose. So we got minus 90, but they wanted answers only between 0 and 360.
Yeah.
And so for our third answer, we would have to take one of our previous two and add or subtract 360. So which of these would we add or subtract 362 to get an answer within 0 and 360?
Minus 90.
Yep.
So 270 you get, so you get the same answer twice.
Yeah, so it's just like a repeated solution type of thing. And so
Okay.
let's not, it's a special case. It's because 270 is 3/4 of the sine graph, I think. Like it's exactly the very bottom there. The exact...
Just on a previous question,
Uh-huh.
sorry. On a previous question, we added 180 multiple times, twice, because it was within boundaries of 0 to 360.
Yeah.
I think.
That's because, so two reasons. One is because the first answer, minus 63 plus minus 63.4, That's outside
Okay.
of 0 to 360. But add 360 to it, what do you get?
296.
Yep,
Okay.
and that's the one we got. And so with tan, when you have a graph, you can see like you add 180, add 180. But instead of having a kind of special case, what you can have is you can always add or subtract 360 from all of them. Like they all repeat every 360. Tan repeats every 180, but if you follow the same thing to get your second solution, do 180 plus, then you only need to remember one method for everything. So inverse, sine, cos, or tan. Then you have the second solution, which is the difficult bit to remember, 180 minus 360 minus 180 plus, and then all three, any of those solutions plus or minus 360 will get you additional solutions. I'm trying to see. I think I'll just leave the rest of these. There's some stuff. Yeah. A student makes an error. That's all right. Yeah, let's try this.
So is the inverse sine of minus 2 equals 5x?
What I would do is divide both sides by 5 first.
Okay. Minus 2 over 5.
Mm-hmm.
And inverse sine of minus 2 over 5.
Yep.
Minus 23.6.
Yeah.
So plus 180.
That'll be for your third answer. How about second answer? For sine?
Is it 360 minus?
For sine, it is 180 minus.
Okay, so all of them are. $203.6.
Okay. And how do we get another solution within the range?
Then we add 180, I think.
That's for tan. For third solution, for all of them.
Okay. Plus or minus 360.
Yeah. Okay.
236.4.
How do you get that?
I did 360 plus minus 23.6.
And say what your answer was again?
336.4.
336.4 degrees. Yeah, I thought you said 236. Yeah. And so what are your solutions within this range?
213.6 and 336.4.
Well done. And yeah, you can keep, it's a circle. If I just go back to this angle, you could keep spinning this circle 360, 360, 360. There's an infinite number of solutions. And so they have to limit it between two things. 336.4 and 203, was it? 203, sorry. 203.6. Great. Okay. How do we do part A? No, I'll tell you what, how do we do B?
Divide by 2 on both sides.
Yep.
So minus root 2 over 2.
Mm-hmm.
And then inverse cos of minus root 2 over 2. You get 135.
Okay.
And that's the first answer. And then 360 minus 135 is 225.
Mm-hmm. And so your two answers?
135 and 235.
Okay, 1, 3, 5, 2, 3, 5. And that is theta. And I think you'd be fine for these. This is a bit unusual. We'll do one with tan. How about question E? No. So, alright, so they've... it'll be a bit tedious. No, let's just cross that bridge when we come to it. So you know how we got these answers, 135 and 235? What if the range was 720? How could you get more solutions?
Just keep adding 360.
Yep, add
until you reach
360
the
to both of them. Add 360.
Okay.
Add 360 to your answers. You know, just keep doing that, and you'll keep getting more solutions. Let's see. Okay. Yep. Let's try this one.
Root both sides, so inverse tan of 3, you get 71.6.
You made a slight mistake. We're half right. X squared equals 9. What is x?
3
Is there another similar number that when you...
plus or minus 3.
Correct. So that tan theta is equal to 3, or tan theta is equal to minus 3. And you just have to do the two separately. You just get double the number of solutions.
Okay. So the first one is 71.6 then.
Okay.
Okay. And then the second one, the same but minus.
Okay.
Minus 1.6.
Okay.
And then you still have to do 360 minus that as well.
That's not the rule for tan. There's our rules. Come on.
80 plus.
Yep, 180 plus.
Okay. 251.6.
251.6 degrees. Okay.
108.4.
108.4.
And then you do minus 365. 360 minus the answer.
No. You can add or subtract 360 from these answers. 360 minus isn't the same as minus 360.
Yeah, okay. That's what I meant.
Now we want solutions between 0 and 360.
So the first one's 108.4.
How did you get that?
360 minus 251.6.
No. 360 minus x is not the same as x minus 360. So with plus, it doesn't matter which way. Minus not the same.
Oh, okay. So the whole time it's been x minus 360.
Well, it'll just always be true. You can add 360 to any solution. You can subtract 360 from it.
Okay, but it is x minus 360. So the other way around.
Yeah, I mean, you'll get a negative number though. We want answers between 0 and 360.
Yeah, okay. So I don't know all of a sudden because
So what are our solutions?
251.6
Right. What else?
and 108.4.
Okay. We have two more. What are the other two solutions we have?
71.6 and minus 71.6.
Yeah. They tell us the range is 0 to 360. And so which of these are not between 0 and 360?
Minus 71.6.
Yeah. So how can you use that to get one that is between 0 and 360?
At 360.
Yep.
$288.4.
288.4 degrees. Great.
Surely, how many answers do we have here?
We have 4. We had to double because tan theta was equal to 3 or tan theta was equal to minus 3. Because of plus or minus 3, we have 4 solutions instead of just the normal 2.
So, say it was, when do we need a third answer, basically? Third and a fourth answer?
When one of our solutions isn't between the range. So one of our solutions was minus 71.6. That's not between 0 and 360. And so you can add 360. Okay. You can use it to get a solution. That is in the range. Let's see. Tell you what. Let me try. I'll try resharing my thing. 1 sec. Share screen. That one. That. And then calculator. Yeah, can you see my calculator?
Yeah.
So you see how I did like sine of 30 minus 360 minus 360. And I get the same thing. So you can subtract 360, you can add 360, and it goes back to being what it was before. So if you have a solution like minus 30, and you want to find one that's in the range, you can just add 360 to it. A minus 30 plus 360 is minus 330. And so it's just a way to get a solution in the range.
Okay.
Okay, how about this one?
Root both of them. So the root of 3/4 is root 3 over 2 plus root 3 over 2 and minus root 3 over 2.
Well done.
And then you do inverse cos of both of them?
Yep.
Uh, 30 and minus 30.
Okay.
And so for cos, it's 360 minus x.
Uh-huh.
Okay. $330.
Mm-hmm.
And then for that one, it's $330 as well.
360 minus 30.
390.
Yep.
But surely that isn't in the range.
Well, neither is minus 30. So let's write down our solutions so far. Oh, actually,
30.
Hang on. This time the range is between minus 180 to plus 180. Okay. And so, which of these are not in the range?
330 and 390.
Okay, so what can we do to make them in the range?
Minus 360 to both of them.
Yep.
So minus 30 and minus 60.
Hang on, so that's going to give you minus 30. This is going to give you plus 30. So are there only two solutions for this? Plus or minus 30? Why did it give me... No, it can't be that. It can't be that. How do we get more answers? 360 minus... Yes. No. 150. How do we get that one? Let's see. So shift cos of root 3 over 2 is 30, and of the negative of that, did you put shift cos of minus root 3 over 2 in? So you can't assume that, Hugo. You have to actually put in the calculator.
Sorry?
You can't assume that. So you said shift cos of minus root 3 over 2 was minus 30?
Oh yeah, no, because the second one was minus 30, so I assumed every single one would be...
No. Yeah,
okay,
so
sorry.
this one's 150. Okay, so this was 150. And so do 360 minus 150.
210.
Okay. And so which of those are not in the range?
Uh, 330 and 210.
Okay, so what can you do to make them in the range?
Minus 360 to get minus 30 and 150.
Say it again?
Minus 30 and minus 150.
Yeah. Well done. Yeah, so they're not necessarily the same thing twice. You have to put in the calculator. Okay, that's
Okay.
good. Theta. Okay, so this is a tricky type of question. I skipped over this earlier. Let me just go back now. Yeah. Oh, I didn't skip over it. I knew what I was doing. Okay. This time we have sine and cos. Any idea how we deal with that?
Do we square both sides?
It's not a bad idea. I have to say, it's not a bad idea. But a quicker way, if you have a mixture of sine and cos, divide both sides by cos. What do you get?
Tan and 1.
Yeah, and so what do we get for this one?
Tan theta equals root 3 cos theta.
Equals root 3.
1 theta, sorry.
Just
So
times,
just root 3 theta.
no, just root 3 times 1. Cos theta divided by cos theta.
Okay.
Anything divided by
Yeah.
itself is 1. So tan theta equals root 3.
Inverse tan of root 3.
Yeah, and then you just solve it the normal way. It'll be fine. All right, let's try A.
So divide cos on both sides
Mm-hmm.
to get root 3 tan theta equals 1.
Yeah. What's step 2 for that one?
Divide by root 3 on both sides.
Yep. What do you get?
1 over root 3.
Yeah, and then you just solve it from there. What would you get for B?
Just a question.
Mhm.
If you square both sides, you get 1. Yes? I mean, if you squares... Oh, no, yeah, you do, wouldn't you?
You would also get plus 2 sine theta cos theta in the middle. Because it'd be like 2 brackets multiplied by each other.
Oh, okay. Fair enough. So, minus cos theta.
Yeah, you
On
could.
both.
Alright.
And then... so you get... Then divide by cos on both sides.
Mm-hmm.
So you get tan theta and minus 1.
Yep. How would you start to see?
Inverse tan of minus 1. Oh, see.
Yeah.
Divide both by cos.
Uh-huh.
Okay, divide both by cos, so 3 tan theta equals 4.
3, yep.
Then divide by 3 on both sides.
Uh-huh.
So tan theta equals 4 over 3.
Yeah.
Then the inverse.
Yeah, and then you go from there. Yep, great. Again, I don't want to bother. Like, this student just did some wacky stuff, you know, just follow the process. So let's see. Yeah, it's an exam question. We just did some that are very similar to it. Sketch the graph, write down how many solutions are there in the range. Do you have a graphical calculator?
Not the one you have, but I do have a scientific one.
But not graphical, is it?
No, I think I lost it or it stolen.
Did I ever send you one?
No, we bought one, but it's fine. I'll ask to buy another one when school starts.
I can send you one if you need one. Sketch the graphs of this thing, how many solutions, and then solve it algebraically. So I don't think that's difficult. This was the one, yeah. That's just a reminder. Alright, yeah, let's do this.
Plus 3 sine squared x on both sides.
Plus 3 sine squared x. Okay.
So 4 cos squared x equals 1 plus 3 sine squared x. And then divide by cos on both sides.
No, that won't work. That won't work. See, you're they want it as this. So they actually tell you they want it as cos squared x, not tan. So how'd you go about that?
You divide both sides by cos, just the way it is now.
That's for tan. How do we convert sine into cos?
Divide by tan divided by sine.
No. How do we convert between sine squared and cos squared?
Oh, 1 minus
Yep.
cos squared. Okay. So 4 cos squared x minus 3. Is that times? Yeah. 1 minus sine or cos squared x
Well done.
equals 1. And then simplify 4 cos squared x minus 3 minus cos squared x.
Times these two as well.
Minus 3 cos squared x.
Minus times minus.
Oh, 3 cos squared x plus 3 cos squared x.
Yeah.
And so from here it's 7 cos squared x and then plus 3 on both sides equals 4.
That's it. And part B.
Divide by 7 on both sides. Get 4
Yeah.
over 7. And then, or maybe root both sides first.
No, dividing's easier.
Okay. Then now root?
Yep.
Okay. Because if you rooted cos squared, did you also have to root 7?
Yes, but you just hit the calculator hard. That's all you do. 4 over 7. Let the calculator do the work.
2 root 7 over 7.
Here you go. Rationalize the denominator. That's why it looks a bit weird.
And the inverse cos of that number.
Is there another very similar number that when we square it we also get 4 over 7?
Plus or minus?
Yeah.
Okay.
So just watch out for that.
40.9 for positive.
Okay. And let's get all the solutions.
And 139.1 for the second one.
And you put in the calculator, did you?
Yeah, that one, yeah.
Alright.
And so we're still looking for more answers now?
We want all the answers between 0 and 360.
But all the answers here are between 0 and 360, no? Apart from minus 4 over 7.
Yep. How do you get your second solution for sine?
Plus 360.
No. That's third solution. Second solution?
Oh, 180.
This is cos.
This is because? Oh, 360 minus the
Yeah.
number. Okay. $319.1
0.1.
and 360 minus 139.1 to get 220.9.
Sorry, say it again.
I can't remember the first one, but the second one's 220.9.
9. Okay, so our four solutions are 40.9, 139.1, 319.1, and 220.9. Let us see. 40.9, 139.1, 220.9, 319.1. Great. Yeah, big picture is you change sine squared x into 1 minus cos squared x. Because, yeah, it'll make it easier to solve. Okay, how do we do part A?
Minus 3 open brackets. So 4 sine squared x, and then minus 3 open brackets, 1 minus sine squared x.
Yeah.
Equals. You put 5, is it not 2?
Sorry, yeah, equals to something wrong.
And then from there on, 4 sine squared x minus 3 plus sine squared x.
Well done.
Oh yeah, 3 sine squared x. And then 7 sine squared x equals 5, plus 3 on both sides.
Yeah, I think at that stage you could write it. And how would you start solving B?
Okay, so it's divide by 7 on both sides,
Mm-hmm.
then root it, you get plus or minus with the answer.
Yeah, and then you go from there.
Okay.
And I think you're okay for that bit. It's just those 4 solutions. Yeah. Oh, we can do it if you want. So this one's very similar. You can see how similar it is. Use the result in part A to explain why the equation has no solutions. Alright, so let's try solving this. So we can skip part A and just go straight to part B.
Okay. Still need to solve that.
Yeah, so how do we solve it?
Oh, so 3 sine squared x equals 4.
Yeah.
It's the beginning. Then divide by 3 on both sides to get 4 over 3. Then get the root of 4 over 3 is 2 root 3 over 3. Plus or minus.
Yeah.
Then, so because sine is 180 minus.
Well, you haven't got an X yet.
Oh yeah, sorry, inverse sine. Oh.
And something's gonna happen.
Just give me a mathematical error.
Try the -1. Should be same thing.
Yeah, mathematical error.
And so originally, well, at this point here, what is 2 root 3 over 3 as a decimal?
I don't know.
I don't know either. I meant in the calculator.
Huh.
Let's see. That's 1.15. And is this one minus 1.15? Yeah. 1.15. Sine graph. Looks like that. What's the maximum? What's the minimum?
90. Minus 90.
No. Maximum height is 1 and -1.
Oh, okay. Is it for all graphs, for cos and tan as well?
For cos, it's the same. The maximum is 1, minimum is -1. Tan just goes the whole range. So sine x is always between 1 and -1. What do you notice about our sine x solutions here?
Slightly above 1 and slightly below 1. So.
Yeah, and so it's those are outside the range of sine x. And so that's why there are no solutions. Sine x is greater than 1, therefore there are no solutions. Yeah. Some mistakes this student made? No. Okay. Maybe we should. Maybe we shouldn't. Maybe we should, maybe we shouldn't. Maybe we'll do part A for this one first, and then part... Maybe I'll regret it, but we'll see. Let's see. So I'll copy that. Put that there. Okay, how do we do part A?
Multiply out.
No. Let's do a teaching question. 2 plus x. Whoops. And 4x 4y minus 1 equals 0. Okay, solve. And you're gonna make me work even harder. X plus 3 x minus 2 equals 0. Let's solve it.
I would multiply out, so
No. You. Can you think of two numbers that multiply to make x?
1 and x.
Sorry,
That
two numbers
multiply it to make x.
to multiply to make 0, sorry.
Oh, anything in 0.
Yep. And so, something times something gives you 0. Either the first one is 0, or the second one is 0. Does that ring a bell?
Okay. Yeah. So x is minus 3 or 2.
That's it. That's from old GCSE. Okay, part 2.
So minus 2. And y. So 0.25 quarter.
Yeah, corner.
So theta is 0 in one of the two brackets.
Yep. Just use what you did up at the top. So if you
I don't know, because
if you did this, have said 2 plus x equals 0 or 4y minus 1 equals 0.
yeah.
Alright, same thing with these two.
So tan theta equals minus 2.
Alright. Yeah. Or?
Or 0. Oh. Sorry, or sine theta equals a quarter.
Yeah. And so you have to find those thetas. So what would you have to do?
Inverse of a quarter.
Yeah, you'd have to solve them.
Yeah, inverse. So inverse tan minus 2.
Yep. And so on. You would then basically just have to solve the two separately. And so
Okay.
you would just like, that one is like inverse, the second answer would be 180 plus, 180 minus for sine. It's just literally solving them separately. So it's like with the plus or minus answers, you'll get double the number of answers. And that's what you get.
Okay.
Let's see this one. Identify 2 mistakes the student made. Write down the correct solutions. Let's just try to solve this and then we'll figure out what mistakes the student made. Any idea how we solve this? We have a mixture of tan and sine.
Dividing by cos x. Is that right?
No. Doesn't matter. Let's just try to solve it.
Oh, just try to solve it. Divide by... Oh,
Well, I think what they did... Yeah, I think what they did was they changed tan x into sin x over cos x. Because sin x over cos x is the same as tan x.
have we done a question like this before?
No.
Okay.
And so try to solve this. How do we... Any ideas?
I still don't know. Do you divide by 5 on both sides?
It's times both sides by cos.
You still get...
Sin x cos
Oh,
x.
okay.
Any idea what's next?
And then... cos x. Do we square both sides?
No. So here's what they did. They divided both sides by cos x.
Cos x. Do we square both sides?
No. So here's what they did. They divided both sides by cos x. Sorry, they divided both sides by sin x. And so that...
Yeah.
But
okay.
the reason why that's not correct is because it eliminates the sin x solutions. The way you deal with this is you bring them to one side together. So 5 sin x minus 9 sin x cos x equals 0. And then you factorize. And so what can you factorize?
Sin x?
Yep.
Let's get 5 minus 9.
What else?
Cos x.
Yeah. Okay. And how do you solve that?
I don't know.
Something times something gives you 0. Either sin x equals 0 or 5 minus 9 cos x equals 0. It's like these brackets. They multiply to make 0. Either the first one equals 0 or the second one equals 0. And you solve the two separately. Know what I mean?
Yeah, I see what you mean, but I don't know how you solve it from here.
Just a normal way. Sin x equals 0.
Inverse sine of 0?
Yeah. What do you get?
Zero?
Yep. Nothing wrong with that. And then the other one they solved for us, and they got 56.3 degrees. And so, yeah, you don't divide both sides by sin x like that, because that removes, it eliminates a solution, because when you do it and create tan, you keep the number of solutions. Yeah, I think I'll actually change the way I teach that, because I think I'll just use pure substitution, because it's a bit misleading. I will see. We'll do another tan thing. Alright, how do we do A? Wait, that's the one we saw earlier, isn't it? Yeah. How do we do B?
Times tan x on both sides?
Yep. What do you get?
And then from then on, so you got 6 sine x
Right.
equals 1 tan x.
Yep.
So just tan x.
Yep.
Divide by sine on both sides.
Nope. This is how we went about this one. How did we had a mixture of tan and sine. How did we deal
Put
with
them
that?
both on the same side and then factorize that.
We did something before that. We changed.
Tan became sine over cos.
Yeah.
So 6 sine x.
Yeah.
And times cos x on both sides.
Yeah.
So 6 sine x cos x equals sine x. Then minus sine x on both sides.
Yeah.
And then factorize out sine x.
Yeah. So do it. What do you get?
Sine x 6 cos x minus 1.
Sine x 6 cos x minus 1. And then? So
Wait,
what did we do after we factorized it?
Okay, so x sine x is 0, or what's in the brackets is 0.
Well done. And so sine x equals 0, or?
Well, 6 cos x minus 1 equals 0.
Well done. And yeah, might as well solve it.
So the inverse of 0, inverse sine of 0 is 0.
Mm-hmm.
And then the other one is 6 cos x equals 1.
Yep.
Then divide by 6 on both sides.
Mm-hmm.
And then do the inverse cos of 1 over 6.
Mm-hmm. What do you get?
$80.4.
80.4 degrees. We want all the solutions between 0 and 360.
Sorry?
We want all the solutions between 0 and 360.
So is it... so for cos it's 100... Is it 360 minus x?
Yeah.
So... $279.6.
How about the other one?
360.
For sine?
Yeah.
Second answer
Oh.
for sine?
180.
Yeah. 180 minus 0 is 180. And so what's all our solutions?
180 or 279.6.
We had two more.
And 0 and 1 over... No, and 0 and 1 over 6?
That's
No.
cos x. What was x?
80.4. Okay.
80.4. Great. And there we go. 80.4 or 279.6. Why did they eliminate those ones? That's bad. That's very bad. I suppose we should check. Ah, I know why the tan one. Because tan 0 is 0, is that right? Yeah, tan 0 is 0 and you can't divide by 0. So that's why 0 isn't a solution. And actually, you can't have 180 either. That's some terrible special case question for you to pick, Bucky. Why would you pick a question like that? Let me see this one. So if you put tan x on the bottom, you can really mess with it. I don't like that. Okay, that's stuff. What do you give yourself?
So that's all of 10.4?
Yep.
That was a long chapter. Not even a chapter, like a section. Yeah, it was same as before, between a half and a tick. Still need more practice here.
You'll get more. Do you have time until 7 to keep going?
Yeah, no problem.
Okay, so let's try these harder trig.
Divide. Divide by 3. No.
It's inside a cos. So you have to get rid of the cos first.
Inverse cos of 3.
Yep. No. Inverse cos both sides, basically. So you have cos 3 theta equals 0.766. Inverse cos both sides.
40.
Sorry?
40. 3 theta equals 40.
Okay.
And so do you divide 40 by 3?
You would think so. And that will get you one solution, but all the others will be wrong. The way you deal with it is right from the very beginning, or at any point, the bit that's in the... Up until now, we've just been doing cos theta, cos 1 theta, sine 1 theta, tan 1 theta. If you have anything else, let, in this case, 3 theta be equal to A. And so A is equal to 40 degrees. And now let's get all of the solutions and we can change it back at the end. And I'll show you why.
Okay. So 40 degrees. And it's cos.
Yep.
So it's 360 minus 40.
Yep.
So 320.
Mm-hmm.
And then...
I think that's all the solutions, isn't it?
Yeah.
And so... Oops. Leave that up there. And so A equals 40. So A equals 40 or 320. And so now we change it back. So A, we let 3 theta be equal to A. And so now we change it back to 3 theta.
Okay.
So 3 theta is 40 and 320. And so what is 1 theta? What is theta?
Divide everything by 3.
Yep. And you get 40 over 3 and 320 over 3. Let's try it the other way.
Okay.
Let's try it the other way. 3 theta equals 40. And so what's theta?
13.3 free return.
Yeah, it's like 40 over 3. And then how would you get the second answer?
Um, 360 minus that.
Yeah. And I'm right in saying you don't get 320 over 3 like you should?
Probably not, I'll check. But
Yeah. It would need to be 360 over 3 minus 40 over 3.
you get 346.6.
Yeah. And so this is the wrong way. And the right way is 3 theta, 2 theta, a half theta, anything theta, change it into a, fully solve it using our normal method, and then solve, and then change it back. It's because of it's Bidmas. We need to do all of the solving first, and then you divide everything at the end. If you divide first and then you add and subtract, you're doing it in the wrong order. Also, the graph has changed. The graph has been squashed in. So if you have cos 3 theta, usually the cos graph looks like that. Cos of 3 theta is like that. There's going to be 3 of them. And so it doesn't repeat every 360 like it used to. It doesn't follow the rule of 360 minus. It follows the rule of 360 over 3 minus. But just so we don't have to think of any of that, we just replace it with a, fully solve, and then change it back and do the little bit at the end.
Okay.
So let us try question B.
Do you divide by cos on both sides?
Let's. What's our let thing first?
Are we doing A first?
No, B.
Okay. So sorry, I don't understand.
Let 2 theta be equal to A. You can call it B if you want.
Okay.
So what would be the question if 2 theta was A?
2 sine A.
Yeah.
Equals cos A.
Cos A. Yep. What's next?
Divide by cos on both sides
Yeah.
to get 2 tan A and equals A.
Yeah. No. Cos A divided by cos A.
1.
Yep.
Sorry, are we dividing by cos or cos A when we do this?
Cos A.
So how come tan keeps its A?
Because sine A over cos A is tan A, but cos A over cos A, anything divided by itself.
Is 1.
Yeah, no matter what the
Okay.
number.
So divide by 2 first, so tan A equals a half.
Yep.
And then inverse of a half. Inverse of tan.
Yep.
.6.
26.6 degrees. Okay.
And
That's
then
one
it's
step.
tan, so it's 180 plus 26.6,
Mm-hmm.
which is 206.6.
Degrees. And so, what are our solutions?
26.6 and 206.6.
Okay, so that's what A is equal to, but we created A. We don't want A, we want theta.
So divide by 2.
Yes, so A is 2 theta. And so 1 theta, divide everything by 2. What do you get?
13.3.
Yep.
Theta equals 13.3 and 103.3.
Well done. And so, let's see. So you can see all the nonsense they did. Absolute bunch of crazy stuff. The tan graph never, see, this is why. Oh, well, what's the solutions? 13.3. Did they get more solutions than us? Did we not get enough? Let's see, we got tan. Oh, I forgot. We've got more solutions to get. I forgot something important. Theta, you know how theta is between 0 and 360?
Yep.
What is 2 theta between?
This is 0 and 720.
Yeah. So we've got to get all them between 0 and 720. So do that for A, because A is 2 theta.
So is it plus or minus 360?
Yeah. Which one? Plus or minus?
It would be plus 360 for both of them.
Yep.
So 386.6.
Yep.
And 566.6.
Yeah. And so get the additional solutions for those two.
Divide by 2.
Yeah.
You get 193.3 and 283.3.
And 280.3?
283.3.
0.3. 283, 193, 103, 13.3. Yep. And so all you have to do, so the reason why this question feels so boring is because it's so similar to what we've done before. All you do is change 2 theta, 3 theta, anything theta to A, solve it exactly the same way, and then do the little bit at the end. And I forgot actually, even with the previous one.
Yeah.
So what would be the range for the previous one?
360 times 3. So
Yeah, I think it's 1080.
yeah.
So there's just going to be loads and loads of solutions. Yeah, great. All right, how about this one?
You do the inverse of sine on both sides.
I would do something before that.
Multiply out.
You can't. It's not being multiplied. It's the sine of x plus 60. Let
X plus 60 be A.
yeah. And
Okay. So sine A
mm-hmm.
equals 0.3.
Yeah.
Then the inverse sine of 0.3.
Yeah.
17.5.
Okay.
And then equals A. That equals A.
Mm-hmm.
And then because this sine is 180 minus 17.5.
Yep.
That gives you 162.5.
Okay.
And so the two answers are 17.5 and 162.5. And then it's A plus 60, so you have to add 60 to both of those.
Well done. So what do you get?
So for the first one, I mean for 162.5, it's 222.5.
Hold on. You're subtracting 60 from both of them, is it?
I'm adding 60.
No. So A is x plus 60, isn't it?
Yeah.
So A equals 17.5 or 162.5. Therefore, x plus 60 equals that. And so how do we get just x?
Minus 60.
You have to subtract 60, yeah.
42.5.
Minus 42.5. So we're subtracting 60.
102.5. For the second one.
Yeah. However, we didn't change our range. This is x plus 60.
So what does that mean?
So the range is x is between 0 and 360. So what is x plus 60 between?
X 0 and 420.
420, yeah. Add 60 to 0.
Oh, 60. 60.
Yeah, so how do we change our values so that they are in between 60 and 420? Or, well,
We have to
one of them is already
we have
between
to
60 and 420. Yep.
add 360 to minus 42.
Yeah. What do you get?
317.5.
300 and... what was it?
17.5.
317.5. And the other one I think is still 102.5.
Yeah, I
Because
think
that's in between 60 and 420. 102.5, 317.5. Great. Yeah, let the thing in the bracket be equal to A, then solve. Let's see. All right, what's step 1 for the first one?
4 theta equals A.
Correct. And what is the range?
360 times 4.
Correct. And so it's between 0 and 4 theta, which is A, and
1,440.
440. Okay. And the rest of those look very similar to me. 3, 2, 2.
180, 0 to 180.
Well done. That's half theta and 180. And a half theta would be A. That's what you would do with that one. Okay. What's step 1 for question B?
A equals 0. I mean theta minus 20.
So you let A be equal to theta minus 20. And so what does the question become?
Minus 20. The range is minus 20 to 340.
Yeah. And what does the question become?
2 sine A equals 1.
2 sine A equals 1. And the range is minus 20 to theta minus 20 to 340. And that is A, which might just make it a bit easier to see. Great. And then you just solve it. You just fully solve it and swap it back. Let's see. Same idea for all these. Yeah. This is what the exam questions look like. They look very similar to what we did. Question 4. Yeah. Let A be equal to x plus 20. Change the range. Same with part B. And then same with the next question. Let's see. Sketch the graph. Yep, very similar. Why is this here? For this one, I think you can use your answer for part A to do part B. Yeah, that's fine. Let's see. No, I think that's fine. I think it's fine. It says tan. Yep. It's a bit weird. That's a bit weird, but I think it's fine. Same idea. There's a little... No, it's okay. Let me just see this one. Yeah. So, harder trig. What do you give yourself?
A tick for this one.
Yeah, we did all right. And so that's the solving stuff. After that, in that chapter is identities, which is quite different. You're not solving anything. You're just swapping them. How was that for you, Hugo?
Pretty good. It's just obviously more practice, so I
Well,
did more questions on my own.
yeah, it's a very challenging thing. Even when you get good at it, you'll still easily make mistakes. And the next section after trig identities is probably the hardest. In all of like year one. But
Okay.
this one is definitely difficult. Trig is difficult. And so
And in year two, do we? Yeah, just a question about in year two, do we cover the same things but pushed further, or is it a whole different topic?
it's mostly same things, just taken to the next level.
Okay.
It used to be that year two was quite different. Like they had vectors, and they didn't have that in year one. But actually, they have vectors in year one as well. So they tried to eliminate that. So it's just, the same type of stuff but pushed further.
Okay.
In the same way, this is like GCSE solving but pushed, much further. Year two is pushed further. Yeah. And so